Hi everyone, I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch. So, hi everyone, I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Twitch. Hi everyone, I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Twitch. Hi everyone. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Twitch. Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't work with Hi everyone on Twitter. I hope you can hear me well. I had some problems with my microphone as well, and now problems with Twitch, like restream. So, doesn't Do you hear me now? Does this sound better? Okay, perfect, thanks. I think the problem was that there was something playing in the background, which got into the stream as well, which I didn't hear because I don't have the sound on. But OBS picked it up. But yeah, I'm glad it's working now. Perfect. So yeah, I've just loaded my Project Euler download package, downloaded problem number 23 because we solved 22 last time, and just read through the problem description. Yeah, so we are looking for abundant numbers, where 12 is an abundant number because the sum of the proper divisors add up to 16, which is more than 12. So there are deficient numbers, deficient numbers, perfect numbers, and abundant numbers. And can you... Okay. Perfect. And we want to find the sum of all positive integers which cannot be written as the sum of two abundant numbers. and all numbers bigger than 28,000 can be written as the sum of two abundant numbers, which is given by mathematical analysis, so we don't have to worry about it. So let's call it non-abundant sum, which doesn't have any inputs. We probably want to have a function called isAbundance, which has an input, and maybe even a function some devices. I hope that's the correct spelling. What we have. Okay. I don't know. I thought we have a function like that. So we just loop over it. We have the sum. Maybe call it like this. So when we have a float input, we would have a float 0, and when we have an integer input, we would have an integer 0. So 0 of is that and 0 of is that, for example. And then if num modulo I 0, and then add it to the sum. And return s, and this just gets sum of divisors of num, and if sd greater than use a hash table to store abundant numbers for speed. Yeah, I actually wanted to use a set for it to get the all abundant numbers up to 28,000 probably. Just wanted to write a function first, which checks whether a number is abundant or not. Because I don't know whether there's a way to get like the next abundant number or stuff like that. So, oh yeah, we can just return if that's correct or not. Maybe oh, well, that's how you write it down. Yeah. And then for I equals 1 to 28, 1, 2, 3. If is abundance I, then push it to abundant numbers. Push I to abundant numbers, and maybe I think we loaded revise, yeah, so we can include and track the solution file. Give me a second. So non-abundant numbers, non-abundant sum. Oh, maybe I should. It's actually not that fast. I wanted to just check whether 12 is in and like 28 is not. What? Oh, I think I have, yeah. So we don't want to go until none, because here it says 14 but not 28, which makes sense. Otherwise it's not well defined, or it doesn't make any sense to have perfect numbers. And now we have 69,000 elements, which probably, oh, okay, I don't know, but I think we had more before. Okay, the next point would be to check whether a number can be written as the sum of two abundant numbers. For example, so Aditya, I hope I pronounced the name correctly. I'm not sure whether you meant something like this or something more reasonable, better, I don't know. The next step would be to use, okay, maybe I should have something like upper bounds. For that, and it's so hot here. And then, what did I want to do? Oh yeah, maybe for abundant number in abundant numbers, if an is the smallest abundant. Because okay, yeah, makes if abundant number is bigger than I, then just continue. Otherwise, difference is I minus abundant number, and then if if diff is in, so if diff in abundant numbers, then add it to the sum and find sum of all positive integers which cannot be written as the sum of, so I cannot be written as. And maybe setting the upper bound to 25 and in out I, just as a test. Okay, I actually wanted, oh yeah, if it's not, because I wanted to have all but 24. Oh yeah, because when okay, because 12 is the smallest one, 1 cannot be written as, and so on. So we can set this to 12 and set this to sum of 1 to 11. I think that should work. I'm trying to go for something that just works at the beginning and then try to benchmark it and try to find a better solution. So the question in the chat was whether I'm trying to get something performance or just something that works. That sounds like quite a massive amount. Change set to bit sets. Ah, okay, and then having I'm a little bit confused at the moment. Oh yeah, so we also want to have a break statement here. Because here it says 25 is not, 25 is not, 25 is not. But we actually want is sum equals to false. And here f, sorry, I have to write it again. So if the sum, if it is the sum, we want to set it to true, which is the case here. And then we can break. And if not sum, we have to add it. 301, which should be sum of 1 to 25 minus 24. Yeah, perfect. Seems more reasonable. Let's check whether it's correct. I don't know why Project Euler always takes so long. Yeah, that's correct. So that works. Let's use benchmark tools. Oh, because I have to. What do you mean by redundant? You mean because it will not go in this part? But I thought that this one will be faster, a faster break. That's why I used it. It's not needed, yeah, but I think it will be faster. But we can check that. So benchmark non-abundant sum. So it's taking 2 seconds. And I was just thinking that this takes quite a lot of time, I think. Oh, it doesn't. Okay. It felt like it's taking a lot of time. But so it's actually this part. Wait. Now I am really confused. And why do we have so many? Yeah, that's correct. But I'm a little bit confused why this takes 2 seconds, but inside nothing takes 2 seconds. Or I'm measuring time wrong. I don't know. No, it was just doing something crazy in the background. Okay, so we are at 31 milliseconds. That makes more sense. Okay, so yeah, if the abundant number is bigger than half of our current number, then we can continue, because otherwise we are in that anyway. So if we loop over it basically twice, and we don't want to get the same number here as we get this number here. And then, so if we get, for example, 2 in the first loop and 3 in the other, we don't want to have 3 and 2 again. This kind of helps with that problem. Okay, but that's not the slow thing. So you said bit set. Can I just use this? Oh, I don't know how. I'm not sure how to work with bit sets, to be honest. But how do you Does this work? Well, that seems a bit odd. Okay, this, by the way, does not. Why did I mess that one up? Was that the reason why one was 2 seconds? Okay, so this is the reason why it's 2 seconds. And then I messed it up here, I think. Then maybe let's check that part again. So that's taking the most time. Okay. And so I'm not sure whether you mean by bit sets that we have basically a list of its abundant number or not, so indicating it with true and false. Because that might work as well, but so this one will be faster maybe, and this one, I don't know, I think a quarter of them are are abundant. Seems like from 6,000, 7,000 or stuff like that. I just wanted to check whether this one works, but it probably doesn't make this one faster, obviously. Let's call that naive. And I have a different version up here. So that will be falses of 2 of upper bounds, of size upper bounds. And then if it is abundant, then we set it to true. What do we have to change here? So basically only need to look in the abundant numbers. Oh yeah, that's true. Aditya mentioned that one only needs to look in the abundant numbers from 1 to middle rather than the entire range. So I think it's yeah, we can do this, and then for I in abundant numbers from R1 to middle, then I think we don't have to do this anymore. But we need to have basically a question, an if whether it's actually an abundant number. So if it's not an abundant number, then we continue. Otherwise, if it is abundant, so because it's abundant when this is true, then we can break because it's a sum of abundant number, and otherwise can stay the same. Okay, we have an error. Oh, I don't want to do that. I want to do this. Okay, I don't know whether that felt faster or not. Not much, say. Okay, it's like, did we have before 2.3? Okay, it's not much faster. But is this? Yeah, probably there are better ways to measure that. So yeah, this is still the part which is taking a lot of time. So probably is this part quite slow to do for every number. So one thing is we could check. Oh yeah, inbounds. But that's not the slow parts. Here, I think this one is actually slow. But and threads might be an option. I agree. Oh no, I didn't want to benchmark that, sorry. But yeah, it's still, that's still not the problem. So one thing, I don't want to use threads. Just because I think you mean my sum divisors is not good? Yeah. So first of all, we could of course do this. The second one is we only have to do it that many times, I think. If that makes sense. Yeah. Okay. Yeah, the other option, but I'm not sure whether that's much faster, is to check, okay, if it's divisible by 2, then it's of course divisible by 14. So for the 28, I mean, if it's divisible by 2, then it's divisible by 14. If it's divisible by 4, it's divisible by 7. Oh yeah, that makes also sense. So if it's, no, wait. No, but I don't want to have the list. So Aditya mentioned in the chat that I can check for all odd numbers or all primes. But I actually want to have all divisors, not the prime divisors. Or well, I could get the divisors out of the primes. That's of course an option, but it's kind of an, I don't know, a hassle to do. So that's what you're suggesting, right? To have a list of primes and then just divide by them and combine them to get the divisors. So for example, for 28, it would be 2 and 7, and then one could generate the 4 and the 14 and stuff like that. That is true. But yeah, and it's maybe also an option which can be used for later project Euler problems. Oh yeah, I think even there's a primes package which gives you the factorization, and then you can get it out of it. But yeah, maybe I'll do that for the next problem if that's all right, and just continue with problem number 24. But yeah, it's definitely a reasonable suggestion. Too many people are writing me. Okay, whatever. So sorry. Lexicographic permutations. I think I can. Lexicographic permutations. A permutation is an ordered arrangement of objects. For example, 3, 1, 2, 4 is one possible permutation of the digits 1, 2, 3, and 4. If all of the permutations are listed numerically or alphabetically, we call it lexicographic order. The lexicographic permutations of 0, 1, and 2 Okay. So this is okay. I assume they order it numerically and not alphabetically, even if they say that both are called lexicographic. But okay. And we basically want to get the sorted permutations of all digits and get the millions lexicographic permutation of the digit. Okay, that seems reasonable. I'm just so there's something like permutations, but I'm not sure which package that is. I'm just wondering whether they have it ordered. I think it's what is a napkin problem is so easy you can write it down on a napkin. Or what is a napkin problem? So yeah, one could probably just compute it, right? Because wow, that looks really ugly on a small screen. So we start with that's then check get the next one. There's an arrow in there. And then we would be probably able, if we think about it for a while. Oh no. Oh my goodness. Something is really going crazy because of revise, I suppose. Does that still work? I'm also not too sure how to. Oh yeah, that's what I meant, I think. So if we have 0 to 9, yeah, then it is actually ordered. And we would basically just need to get the millionth element of it, which can be done quite easily with that. So a very simple solution is I don't know, number 1, 2, 3. I hope that's a million. We close that. Oh, by the way, can I index it directly? No, I have to collect it. Because digits exists, I call it dix. Perms is collect of permutations of dix. Return which can be a slow solution. I agree on that, because we okay, I should be able to call it like this. So it's 2, 7, 8, 3, 9, 1, 5, 6. Let's check. What did I want to say? Because we have to, or I create an array for it. I collect it. Oh yeah, we can iterate over it, I think, and then we can get it faster. But we could, of course, also implement it ourselves. Why does it take so long? Okay, but it's the correct solution. Only need to compute the factorial. factorials? Sorry, I don't know what I said at that moment. What do you mean by factorials? Is it about the permutations problem? Because we okay, because you mean what is 10 factorial and then get the number of solutions and so on, I suppose. Is that what you mean? Or basically how many changes we can make in the first two, in the last two digits and the last three digits and so on to get the solution. Okay, let's, oh yeah, I also wanted to, okay, I think, yeah, that's more what I was looking for actually as the answer. Just want to check how slow that actually is with all the allocations. And yeah, but yeah, I normally, oh, it's also really slow. This will become an ON solution minus the number of digits. Oh yeah, that makes sense. I just wanted to check whether this this is probably much faster, right? Okay, didn't feel much faster. Oh no, why do I still collect? Because then we don't have the memory allocations. Because what permutations this function probably does is to generate them one by one. Yeah. We still have quite a few memory allocations. Why is that? That seems a little bit odd. But yeah, it's definitely much faster now without the memory allocations in. Oops, right? It's probably doing memory allocations in between. But why so many? That seems quite a somehow. Because it should be relatively simple to just iterate over them without doing memory allocations. But that's just my thinking of it. But okay. So about the other solution would be to compute it directly is basically if we set 0 at our first position, then we have I think that's a function here. Yeah, so we have what is that? 362,000 possibilities, which means That's 300. What do we want? 2, 3, 2, 3. So yeah. So basically, we can find out that there's no 0 at the first place and there's no 1 at the first place, but there's a 2 as the first place. Because when we subtract it 3 times, it's less than 0. Yeah, do you have any idea why it is so slow? Or, like, I don't know, it seems slow, right? I think it should be faster. Bad implementation, yeah. But I would think that it's that they thought about it more, because I think I don't know, it seems like from Julia math with quite some people which implements quite a lot of stuff, or assume that they that they know what they are doing. This window is too small for me. Oh my god, sometimes I just hate Linux. I don't know why it's taking so much time. I wanted to look permutation. I know I can do that from the REPL as well. Because they also have okay, I think we should do this way. It's so hard to look at. You know what? Yeah, it might be something one can approve upon and just make a pull request on it. Oh, there are some issues. Slow permutations. Slower than it should be. Euler's example I discovered. Have an area of string. Okay, maybe it's like I hope you can read it as well. Probably no allocations. This is to I'm a little bit confused what this is actually doing right now, or count first what it is actually returning. It seems a little bit odd to me. Yeah, I think there are definitely ways to improve on it. What is that? Yeah. Yeah, exactly. That's super weird. So this is just writing an iterator for it. I wrote an iterator for something else on this stream before. And yeah, it's 40 times. So that is super weird. Anyway, I don't know why the people are not interested in it to just get a better solution out of it. They are at least aware of it now, or they should be. So yeah, let's get back. So we solved the problem, and we could, in theory, directly. What I want to do? Directly solve the problem by just having a look what is the first position with doing this, or basically let's see the chat. Wait, it was May 2020, right? Not May 2013. Yeah, seems to be this year. Otherwise, yeah, that would be no. That would be weird. That was the wrong click. No. I want to resubmit it. Okay. Do we still have the answer? Lexicographic Permutation. We don't have an input for that, right? We have default input. Okay. Whatever. By the way, Aditya, what are you working on? How long are you coding in Julia for? I'm glad you found out about this stream. You're coming here from Slack, or how did you find it? So what I wanted to do was to have GPU stuff. That's nice. I only worked on GPU stuff for my Mandelbrot video on YouTube. Coming from Slack, perfect. that's the only thing I ever did with GPU, I think. Computing the motherboard's head faster. I was quite impressed on how easy it was. But I assume there are some things which are hard to implement in the GPU. I haven't worked with, I think I tried out custom kernels once, but never really used them anyway. But it's somehow on my list. So I wanted to do yes, and then let me think about it. So how do I write that? I don't know. It's a vector which has zeros int of length of digits. There's length, right? Yeah. And for I equals to that, we have factorial is factorial of yeah, of the length. So at first 9 would be to have GPU abstractions through native Julian frameworks like broadcast map and do GPU stuff without worrying about custom kernels. Yeah, no, that's true. Yeah, I don't know what I actually used in the end, but some kind of an abstraction layer. So it was quite easy to just say do it on the GPU, which I liked. But someone mentioned in the comments when I posted the video, when I published it, that there would be a speed up doing it with custom kernels. I haven't tried that, to be honest, but I think it's always good to have the high level option for just doing things easier, but there's always some advancement when you do the low level option to get better performance. That is expected. So I wanted to have div of n is basically I. Oh, and then oh yeah, I'm not I'm just thinking that I don't want to, when I found out that the 2 is used, I don't want to use the 2 again, which I'm currently not too sure how to do that. So the idea was to use, I don't know, use n modulo as the next n. Sorry, this should be an I. And then we have 2, 6, but we used the 2 already, so this should be a 7. Then we use the 2 and the 6, so this should be an 8, and so on. I hope that makes sense. Just not too sure how to write that. Okay. Let me have a drink. Maybe have something like used with the digits. If yeah, now I would assume that I use digits starting from 0. Maybe just implement it first and think about that one later. So I haven't used any one of those. I could also call it digits up to or stuff like that, and it has to start with 0. So used of I plus 1, because indexed by 1 starts indexing at 1, but we have the digit 0 is set to true. And if maybe like this, counts I think counts used from 1 to digits, and this will be added to it. I hope that makes sense. Okay. Oh, why I? Wait a second. I don't use I use basically this. But it's still weird. Okay, let's check that out. So 2 is correct, 7 is correct, 7 is wrong. And I also want to have maybe also have used. So I used, wait a second. Okay, I want to write that down there, but it seemed wrong. So I used the 2. So this one is 2. I wanted to have that. 2, then 7. Do I need to have this? No. Okay. So counting, so digit is 6. Okay, because it's 6. Thanks. Yeah, I was quite happy with my Mandelbrot. I tried a zooming version, or I did a zooming version, which you can see at the beginning of the video, which I didn't live code there, because that one was a little bit hacky. That I don't want to show the code of that. And yeah, it was only live coded, so I checked out beforehand how to do it and then just coded it live. Whereas this I have never coded before. This is actual live coding. So yeah, I would set, so here I would set a 6, and then I would jump to 7 and would see that the 7 is already used. Okay. So then I would need to maybe have this. That makes sense. And then while use of class 1 f dig plus equal to 1, and then something like that. 783915. That looks relatively good up to this point. So did we do something wrong in between? Or where does it fail? That's the question. I probably should have. Digit is 6. We added to 7. Digit is 6. We added to 2. Digit is 2. We have to already set it to 3 and fill that up. Digit is 5. But we have 2 and 3 already. Wait. 2, 7, 8, 3, 9. Okay, so the 9 is correct. 5. 5 would be pushed to 7, but we already have 7. So 8 and 9. Yes, makes sense. The 1 is also used reasonable. Then we have 2. 2 can't be used. Or 2 is pushed to 4 because we used 1 and 2 already. And then the 4 is used. That kind of makes sense, but is the wrong result. Why is that the wrong result? We have used 1. Oh, and this one is also wrong then. Oh, yeah, okay. But this is still correct, right? Because that's just the number of possibilities. And we want to have... Oh, we could also... I don't know whether it's... So the other option is we could collect the open possibilities. So have 0, 1, and then just remove. Do we actually have? Remove item. Remove by index. We need to find the index. Okay. Whatever. So and that was what I was thinking about, to have kind of the possibilities and then find out where the 2 is. So have, I don't know, I think something like that should work. And then have a splice. Call it A, and then have splice A3, and A is then the rest of it. Maybe that's easier to read than this one, and I don't know whether it fixes the bug. And then have basically this is open digs of dig plus 1, because it starts with 0, and then we have splice open digs. And we have used this one. So find first where this is true. Uh, 278391546. It's a different error, but it's not correct. Okay, maybe we should do... Okay, that's also wrong. So we have, let's check out. We have 24 possibilities. We get 24 factorial of 3, which is oh, why 24? Oh, I want to have 2 factorial of 3, exactly, which gives us our 0. Sorry, what is our? So, and then we have basically still 2 left, and have 2 again, just with 2, which gives us a 1. Because factorial of 2 is 2. Is that the problem? Okay, so we basically want to go into this. Yeah, I think if it's directly divisible by, we actually want to have the lower, we actually want to have 1 less. I don't know how to best describe that, but basically if and have something like that. Don't want to have it with anything. 1, 5, 4, 6, 0. Perfect. Damn it. That took longer than expected. And right. I didn't write down anything. Oh, because I tested. Damn it. Tested naive. Oh, damn it. Work. Yeah, I'm wondering in the end whether it's Okay, yeah, if it's 0, then just have dig to 0, I guess. N is 0. But why? What? Sometimes I just don't get it. Didn't I save? Okay, so this is still wrong. And it's wrong at the end. So we have yeah, I know. Not a good way of debugging it. For actual digit. So somehow, but if somehow n is 0, is that actually the first error? 2783915 Yeah. Do I actually want to have it modulo? Or do I want to have I don't make any difference. So in the end we have 4. And then, yeah, why is it not 0, 6? I'm a little bit confused. Because we would have it ordered. There's some weird thing of this n. So the factorial of 2 means that we have 2 possibilities in the end. 0 and 1, 0 and 6, and 6 and 0. Kind of. And because 4 So we have, in the end, it's either 0, 0, 4, 6. 0, 6, 4, 4, 0, 6, or 4, 6, 0. Right. And we are at possibility number 4, which makes this the correct option. The problem is that in the end, we say that we want to have possibility number n. Oh, because we start. Okay, let me yeah, I think the only thing we have to change is because we have one index-based thing, kind of, that we need to have n plus 1 at the beginning, because we want to have basically if we have 0 here, we actually mean that we want to have the first possibility. And if we start with n equals to 0, so this doesn't give us anything, but this gives us 0, 1, 2, 3. With my check. Okay, there is something more wrong. Yeah, because this one is the actual option. So we have some problems at the beginning. Let's think about those again. So it's probably something going on here. N equals to 3. Yes. Factorial is 2, which gives us 1. But 0 is used, so this would give us 2. Which kind of makes sense, right? Do we need a -1? Oh man, doing something really wrong. Yeah, basically, if this ever gets 0, I want to have it 1, based on my knowledge, or based on how to say. So basically, if we want to have the 0th position, but then the other one should. Okay, So the problem is if I ever get a 0 in the end, my algorithm is kind of one index based. Besides probably this problematic thing here. Okay, let's check that. We still have 3 left. And the 3 left, oh no, I don't have 3 left. That was with my 2. Yeah, okay. So this should give 0, 1, 3, 2, but it gives us 0, 1, 2, 3. And basically n is 0 here, which makes actual digit 2. Factorial 1. Yeah, so this one should be 1, right? But I don't know whether that's not always wrong, right? Basically, if n equals 0, then n equals 1. But this seems so weird and is still wrong. Okay, if there's someone in the chat who freaks out right now, please help me out. What can we do? Okay, so if we want to have the first, let's write that down. If we want to have the first, we always get the digit which we always get just the first by having digit 0, 0, 0 all the time and just selecting the next one. That makes sense. Okay. If we have 2, we get digit is 0 because it doesn't fit into 6. We have digit 2 left. Factorial, digit is 1. We used, we didn't use 1, so that's all right. And then factorial is 2. And this just how do I handle the 0 correctly? Well, actually, it should be still 2, right? What if I do minus digit or like not the actual digit, but yeah, okay. So that we have the correct digit from there. That somehow seems reasonable. 15460. Thank you. Oh man. Yeah, and I should probably document that somehow. But at least it's not, I think it was milliseconds before, and now it's microseconds, which better. Yeah, it was 200 milliseconds, and now it's 2 microseconds. That's nice. Okay. I think I have test cases for it, or one test case. Perfect. Okay. Solve that one. It's already near 2 hours now. So let's just read the next problem. And if it seems really easy, then I might do it. And otherwise, I will do it next Wednesday. And yeah, by the way, I also want to have, want to make a stream on the Pascal's triangle, probably the day after tomorrow, so on Friday. If you want to see that, maybe you can type in the chat that you want to see it, and maybe, I don't know, the time that works best for you. So for me, it would be either 3 p.m. UTC, so when this stream started, maybe 2 hours earlier, 2 hours later. That's all fine for me. Yeah, so I want to show some visualizations. I have to code them first. So I code some visualizations for it and what can be seen in the Pascal's triangle, like Fibonacci sequence, tetrahedral numbers, square numbers, and that kind of stuff. 11 to the power, like 11 to the power of 2 to the power of 3, and so on. There are a lot of things. So if you have any ideas, please also send them to me now or just during the live stream, and try to implement them as well. So yeah, that's the plan for that. Now let's have a look at the Fibonacci number. By the way, did we do anything with Fibonacci numbers before? Even Fibonacci numbers. Okay. The Fibonacci sequence is defined by the recurrence relation Fn equals to Fn minus 1 plus Fn minus 2. That's the first 12 elements and so on. Yeah, the 12th element is the first term to contain 3 digits. Okay, what is the index of the first term in the Fibonacci sequence to contain 1000? Seems like one can use big int for it and probably get a reasonable solution. And yeah, the other way is probably, I don't know, one could, but can one compute? Okay, I don't know. Let's download the problem and try the big int solution first. And maybe, because I've struggled a little bit in the stream, can think of a better solution. Digits, or maybe digits. I don't know, something like that. And we have a test case for len equals to 3, and that is 12. So we don't have, so basically we have a counter which is 1, and then return counter, or basic, because we have basically we have starting with 1 and 1, and the counter is set to 3 and c plus 1. We want to break if we have big ints and if n digits of next equals to contain 1000. I don't know. Maybe we should do it like this. I don't know whether that makes sense, but it seems kind of reasonable. Digit 3. Sorry. Then yeah. Is that the answer? Yeah, I would be faster to do. And yeah, compared to some, that is the answer. To some others, 1 new awards. Solve 25 of the 50 easiest problems. Yes. Easy problem is milliseconds still, but okay. Yeah, well, big int kind of a hassle to work with. Or like, they're not that fast. They work, right? So anyway, thanks everyone for watching. And because I am supported by Patreons, 7 people support me via Patreon at the moment, and the 3 of them you can see here spend more than $4 per month, and I normally don't I just wanted to write my blog in the chat. So normally I blog and not live stream. Sometimes I make videos like you see on this YouTube channel. But most of the time I do some blogging, and you can let me let me open that for you. So the blog is opensource.as. And until tomorrow, I have a Patreon special. So if you subscribe for $4 or more per month, we have like an hour one-on-one chats with me where you can just ask me anything you would like to know about me, tell me about yourself, as I'm interested in what you're working on, as well as just talk about the blog. Maybe you have some ideas for the stream or whatever. Just a nice way of having a small chat with me, and I hope I can learn more about you. So I have these specials from time to time. Like I had one, I don't know, probably it was March, which was quite nice. And yeah, if you don't want to spend $4 per month, I'm also very happy if you just spend $1 per month to support me. You get everything 2 days earlier that I produce, besides live streams, of course, which wouldn't make any sense. Yeah, all the blog posts. So I have published a new Julia Basics blog post in the morning, which you get the link on the Patreon page if you're interested in, and I will publish it for everyone on Friday. And when I make YouTube videos, which I don't do that often, to be honest, you also get them 2 days earlier than everyone else. And it's just a nice and easy way to communicate with the people who want to support me. So if you're one of them, thanks. And if you want to become one of them, thank you so much for supporting me. And yeah, I also want to thank my friend for the intro music, which hopefully you were able to hear. I know I had some microphone issues before, but I'm not sure whether I had them during the intro music performance. So thanks again for the intro music. And yeah, see you on Friday if you want to join the stream on Pascal's Triangle. I will announce the time on Slack, of course, and on Twitter as well. So thanks everyone for joining, and especially Aditya. I'm not sure whether you're still here, but thanks for giving me some hints during the problem session. And yeah, see you next time.